Hi everyone. So today in this video I am going to discuss with you one of the topic from the CSR NET or KSET exam, that is numerical integration. This is the topic from numerical techniques. So numerical integration is very important as per the exam point of view because you can score maximum marks from this topic. So let us discuss. So one of the question will be compulsory from this topic. So first we need to understand numerical integration. As we know, integration is what? Area under the curve. So here you can see the x-axis and y-axis. So here is the area under the curve. Integration is nothing but the area inside this curve. This curve is given by the function f of x. Okay, it is uh, having the limit a to b. So numerical integration comprises a broad family of algorithms for calculating the numerical value of definite integral. So here whatever the integration of the given function you will have numerical value of this given function in terms of numbers. Numerical means for the given definite integral a to b, if you take, this is what definite integral. So let us discuss in detail about the numerical integration, and different methods are there to calculate the numerical value with the help of numerical integration. The general formula of numerical integration may be stated as follows. This is the general formula we can observe here. Given a set of data points x0, y0, x1, y1 and xn, yn, data points if we take, of a function y equal to f of x. Here this y will depend upon the x. Okay, y is given by what? Function of x, which is divided into the intervals x0, y0, x1, y1 and so on. So here if we take y0 is going to depend upon the function of x0. So like that up to n values we can take here. When f of x is not known explicitly, it is required to compute the value of definite integral. So at that time, if f of x is not known, with the help of definite integral a to b, the limits, with the help of that we can find out the numerical value. As here is the equation general formula for numerical integration, I equal to a to b y dx. Let us consider this as equation 1. As in the case of numerical differentiation, we replace f of x by phi of x. So different integration formula can be obtained depending upon the type of integration formula used. So as we come across the different methods, I will discuss in detail about them, which are the methods and how we obtain those methods with the help of this numerical integration general formula. So let interval a comma b be divided into n equal sub-intervals such that a is equal to x1, x0 which is less than x1, x1 which is less than x2 and so on up to xn. So a and b are divided into interval. You can observe here in this equation clearly. xn is given by what? This xn is equal to x naught plus n into h. Intervals, whatever we are dividing this interval a to b into different intervals. Okay, this h value, if we take, is given by this equation. If we take the interval x naught to xn, we can write h equal to xn minus x naught by n. So this is the formula to calculate h value, which is divided into number of intervals. So approximately y. Here is the general formula. We have to replace a and b with x naught and xn and f of x as that is y equal to f of x, y dx, keep as it is. So y by Newton forward difference formula we obtain here. I is equal to x naught to xn. I can write as it is. Y will depend upon the interval. A and b are divided into different intervals x naught, x1, x2, xn. So for x naught we will have y naught. Okay. With the help of numerical differentiation formula, if you study numerical differentiation, you can understand this formula. P is the interval delta y naught plus p into p minus 1 divided by 2 del square y naught and so on. Since x is equal to x naught plus ph according to numerical differentiation, if you differentiate it, dx equal to h dp you will get with respect to x and p if you differentiate. Then substitute this dx value in this formula. Then you will get here the required formula. So here the interval x naught to n, we can write it as 0 to n, and y naught as it is p, write the formula as it is, only replace here dx, you will get dp, and here you can get h outside the integration, which gives on simplification here I is equal to what? Integration x naught to xn y dx, keep as it is, and here n into h. On simplification you will have the equation 2 here. If you integrate with respect to 0 to n and put the limits 0 and n in this equation, you will have n into h y naught plus n by 2 del y naught plus n into 2n minus 3 divided by 12 and so on. From this general formula, we can obtain different integration formula by putting n equal to 1, 2, 3 and so on. So here are the different methods as I said, trapezoidal rule, Simpson's 1 by 3 rule, Simpson's 3 by 8 rule. So first trapezoidal rule, if you want to get, you have to put n equal to 1 in this equation. All differences higher than the first will become 0 and we will get this trapezoidal rule here. Condition is x naught to xn as we have the limit. So first you should take x naught to x1. You will have this formula. If you then x1 to x2, if you put, you will have the second equation and so on up to xn. If you take or add all these terms, then you will get here the required equation for trapezoidal rule, that is x naught to xn y dx equal to h by 2. Take outside the bracket, and here you will have y naught plus 2 into y naught, y1, y2, y3, so on, plus yn. You should multiply here 2, except y naught and yn outside the bracket should multiply 2 with other terms for the given interval, which is called trapezoidal rule. So Simpson one-third rule, if you put n equal to 2 in this equation 2, you will get 1/3 rule, Simpson. So again you should take the interval x0 to x2. Here even number of interval you should take, and replacing by n by 2 arises of second degree polynomial here. So x0 to x2, x2 to x4, even numbers you should take, xn minus 1 to xn you should take. Add these terms, individual terms. If you add, you will get the Simpson's one-third rule. H by 3 y0 plus 4 into y1 plus y3 plus y5 yn minus 1. Here you should multiply with 2 for even numbers, y2 yn minus 2, for odd numbers multiply by 4 y1 to yn minus 1, and here y0 and y4 you should take outside the bracket. So here in trapezoidal rule you should multiply all odd and even numbers inside the bracket with 2. Here you have to subtract the odd numbers and even numbers in Simpson one-third rule. Simpson 3/8 rule, if you put n equal to 3 in the equation 2, we get the required Simpson 3/8 rule. First take x0 to x3 here. Okay. N equal to 1 if you take x0 to x1. N equal to 2 if you take x0 to x2. N equal to 3 if you take x0 to x3, you should start. And here x3 to x9 they have given, and at the end if you add the individual terms by putting the limit x0 to x3 and so on, you will get here 3h by 8. Here you should add y0 plus 3 y1, y2, y3, and in the next bracket y3, 3 y4, 3 y5, y6, and so on. In this bracket you should write yn minus 3, 3 into y, n minus 2, 3 y into n minus 1, and yn. So if you observe for 3h by 8 rule, y0, 3y1, 3y2 plus y3. So 0, 1, 2, 3, and if you take second bracket it will start with y3, y4, y5, y6. So like that you can apply this rule here for 3h by 8. If you simplify these brackets, then you will have y0 plus 3y1, and just if you take these terms outside the bracket, you can write again, and final equation you will get. This is 3h by 8 rule. Once you know how exactly these methods arises from the general equation of numerical integration, then you can solve the given equation. in exam. So here is the final equation for Simpson rule 3h by 8 y0 plus yn take inside the bracket plus 3 into y1 plus y2 plus y4 y5 and then in the second bracket you should multiply with 2 y3 y6 plus yn minus 3. So these formulas you should keep in mind and let us solve, and you should write these formulas, practice them. In exam you should able to solve directly the given question. So let us take one example here, then you will clearly understand these different rules, methods. Find from the following table the area bounded by the curve. The x-axis from x equal to 7.47 to x equal to 7.52. So you can apply any of the rule here. They are not mentioned particular method or rule here. You can apply trapezoidal, Simpson or Simpson 1/3 or 3 by 8 rule. So let us solve this by trapezoidal rule. Here in this question, they are given the interval here, x equal to 7.47 to 7.52. So you can divide them into 5 intervals here. So first write down here in this tabular column x value 7.47. Each time you can increase by 0.1, 7.48 and so on. So total how many intervals? 1, 2, 3, 4, 5 intervals. Okay. And here if you take y is what? Function of x. This is nothing but y is equal to f of x. Here this is y0. If you substitute x value in the given function, then y1, y2, y3 values you will get. So here h is equal to what? Xn minus x naught by n. Xn is what? 7.52 minus 7.47 divided by n. How many intervals? 5. So you will get 0.05 by 5. So this is what h equal to. So by using trapezoidal rule, you can substitute the value of y0. So as in the question they are given the area bounded by the curve is equal to integration of f of x. So h by 2 y0. If you substitute in the function, you will get y0 equal to 1.93. Substitute that, and 2 into y1 up to y4 values you should substitute here, and y5. If you add all these terms and simplify, final area and the curve you will get. This is how you can solve this problem. So let us go for another example. Apply trapezoidal Simpson 3 by 8 and 1 by 3 rule for the given integration. I is equal to 0 to 1 root 1 minus x squared dx. So here f of x is what? Root of 1 minus x square. Then y is equal to f of x. You should take here 0 to 1 they have given limit. You can divide this 0 to 1 into different intervals 0, 0, 0.2, 0.4, 0.6, 0.8 and 1, so on. If you put x equal to 0 in this equation, root 1 minus x square, you should put the value of x in this given equation 1 minus x square. So why not value first x equal to 0 if you put, you will get 1. If you put x equal to 0.2, y1 value you will get 0.2 square 0.04. So 1 minus 0.04 if you do, you will get 0.97 something. So this is y1. X equal to 0.4 if you put, you will get y2 and so on. By using y equal to f of x root 1 minus x square. Then here how many intervals are there? 1, 2, 3, 4, 5. 5 intervals are there. So h equal to 0.2, that is h equal to xn minus x naught. Xn is how much? 1. X naught is how much? 0. Divided by how many intervals? 5. So 1 by 5 is equal to 0.2. So after getting value of h, you can go for the first rule, that is trapezoidal rule. This is the standard formula for trapezoidal rule. I equal to h by 2 y naught plus 2 into y1, y2, y3, y4 plus y4. Okay. Then 0.2 by 2 if you do, substitute y naught, that is 1 here, 2 into y1 0.9798, y2 916, y3 0.8.6. Okay, y5 is what? 0. Then add all these terms and multiply with 2 inside the bracket. Then after that, finally you should multiply 0.1. You will get the required answer for trapezoidal rule. 0.750. Okay. So this is the value obtained from trapezoidal rule. If you go for Simpson 1/3 rule, this is the formula to calculate Simpson 1/3 rule. Write down the formula first, then substitute values of y naught and up to y4. Here up to y and n equal to how many intervals? 5. So y5 up to y5 should substitute. First, if you write down the formula, you will get how to substitute values. Y0 plus 4 into odd numbers. Here y1, y3, y5 are the odd numbers. Multiply with 2 with even number, y2 into y4. Only y2 you should multiply, and this last digit you should keep as it. Okay. Then simplify this equation. You will get I equal to 0.7038. First thing is to remember the formula and then substitute the values properly, multiply the values, you will get the required answer. So 3 by 8 rule. First write down the equation 3h by 8 into y0 plus here 3y1, 3y2 plus 2y3, 3y4 plus y5. So you should know the Simpson 3 by 8 formula. Here is the general formula y0 plus yn in plus 3 into inside the bracket you should take the terms n minus 2, n minus 1, and here n minus 3, that is y3, y6, y9, like so on. From the for the given function with these intervals, we can write here y0 plus 3y1 plus 3y2 plus 2y3. y3 is only the term, that is y6 we don't have, so y3. So these terms you should make a group here, 3 into y1 plus y2 plus y4. Okay, these two and this one you can multiply with 3, and this is 2 into y3, and last term keep as it is y5. Substitute values here and multiply with 0.75 3h by 8. You will get the required answer, that is I equal to 0.7567, which is the answer that you get from Simpson 3 by 8 rule. So like this you should solve the numerical integration problem. So numerical integration is nothing but the getting the numerical value of the given definite integral. So like that you should solve many of the problems. You will get the idea how to solve the problems related to numerical